For the theory, the motion of a body that oscillates back and forth is defined as a simple harmonic motion if there exists a restoring force is opposite and directly proportional to the distance x that the body is displaced from equilibrium position. This relationship between the restoring force and displacement s may be written as F equal to negative kx. When an object is hanged to a spring and were to let to equilibrium, the total force x on it is 0, where Fy is the force on the y-axis. For the apparatus, we need to use helical steel spring with supporting stand and scale, a set of slotted weight with hanger and weight balance.
So, for the procedure, first of all, the mass of hanger already measured and recorded. Second, the weight of the hanger already have been calculated and recorded as W in the table. Third, the scale adjusted so that the pointer of the hanger is near the upper end of the scale when the hanger was already unloaded. Its position recorded as x0. Number 4, the hanger loaded by 10 gram mass. The scale reading, known as x1, also recorded. The load keep increasing by suitable increment, which is they need to be equal to obtain 8 data points before the lower end of the scale is reached. All of the data have been recorded, which is W and x1. For the step 5, the process already reversed by unloading the same loads as in the step 3. The new scale reading, which is x1, has already recorded again in each load. For the step 6, the extension of the spring already calculated. And for the last step, the extension force that acted on the spring, which is F, for its total loads have been determined.
That we obtain after we are done with the experiment. Now we are getting into the analysis. For question 1, plot a graph of the force causing the extension F against the extension X. Calculate gradient of the graph. What value does the gradient represent? Firstly, you will have to plot a graph against weight of loaded mass and hanger against extension of the spring, and then when you will get the extension force after you obtain extension force, then you can plot the graph extension F against extension X, and the gradient represents the constant extension of force, that is N, and this is the graph that we obtain based on the result. Question 2, how much work done in stretching the spring through 0.2 m? Find this from the graph. As the result shown, that we did not reach 0.2 m. Thus, there are no work done in this case because the extension of spring does not pass 0.2 m.
Furthermore, how much energy is stored in the spring when it is extended to 0.20 meter? There is no energy stored in the spring as the result obtained does not exceed 0.20 meter. Moreover, describe any errors that may have occurred during the experiment. So the answer for that question is, based on the experiment, it has systematic error, which is negative 0.0002 meters. Other than that, what can you describe from your result about the relationship between the extension of a spring and the force causing extension? So the answer of that question is, the higher the mass of the weight, the higher the stretching force is needed to stretch the spring.
So for the conclusion, based on the experiment, the accuracy of the Hooke's law is already verified. Every free object is acted on by the gravitational force of the acceleration, giving it its weight. The higher the mass of the weight, the higher the stretching forces is needed to stretch the spring.